Hello, I am Arguello from Colorado, and this is the second part of my video talking about the eye and some of the layers of the eye. Um, so I'll be trying, I'm not the greatest artist, but trying to draw a picture of the eyes connected to the brain. So the optic nerve, I should remember, is connected through the temporal lobe to the back of the brain, which is the occipital lobe. So, please. So I'm going to start off, and hopefully I might have to have confidence. But anyways, so we're gonna be talking about the anatomy of the eye, some of the eye. So, and again, I will try my best at drawing a picture. I am not an artist. Okay, let's see. Should I start with the pencil of me trying to draw the brain? Okay. So, how can I do this? The eyes and the brain. Okay, I could start off maybe here. No. See, I'm not an artist. Yeah. Basically, the person's nose. I wish I could draw, and then their mouth. I think I draw to save my life. Nose, and then the mouth. That looks horrible. Ow. So far that's the picture I'm trying to draw. It's a side picture. Sorry that you could barely see it. I should probably trace over it. Ow. I really hurt myself. I just stabbed my foot. So I'm going to trace over this to make it look darker. It was easier to draw the side face of the person just because it's easier to see. You can see one perspective of the eye and the brain, especially when you're not an artist like me. So here's a better picture. I'm just gonna leave these all on. So here's a better picture of the, I can't even think today, of the side portion of a person. That's supposed to be the nose. But anyways, so now I'm going to draw the eye, which I'll use, well, first a pencil. So here's my eyeball. And then I could even draw the iris of the eye, which is the color of the eye. Crazy. Okay, so here's my eye, iris, and then the color of the eye. So, okay, there's my eye. That's my eye. So now I'll draw the optic nerve. So the optic nerve goes from the eye to the back of your brain. So the optic nerve goes from your eye to the back of your brain. It's like a big wire. It's crazy. So this is my optic nerve. Optic nerve. So the optic nerve travels to, so there's the eye, then the optic nerve, then it travels to the optic radiation, I think? Yes, optic radiation. Optic radiation, which then is connected to the brain. Well, it is all connected to the brain, so I take that back. So the eye and the optic nerve is like on the temporal side of the brain. The optic nerve is probably on the temporal side of the brain. Oh, that's an ugly brain. Temporal side of the brain. And then you have your hemispheres, your right hemisphere and your left hemisphere. And then in the back, which is your occipital lobe. So there's like 3 layers, I think. Well, we'll get into that. So there's my, that right there is like my occipital lobe. Right here. So there's the eye, the optic nerve, which is in the temporal lobe, then travels to the optic radiation, which then travels into the occipital lobe. The occipital lobe. So see the connections there? So I'll color in the occipital lobe. I'm gonna go get another color. I'll be right back. Okay, I'm back. So for the occipital lobe, I'll use orange, brown, and this color. So for the outer layer of the occipital lobe, I'll color with this color. Why isn't it working? Okay. It's better to see when it's colored, coordinated. Okay. Okay, and then I'll use the orange for this middle layer. This is how I see it anyways. And then brown. Oh, that's just. Okay, so these right here, this right here is your occipital. Is that how you say it? Occipital? I think so. How do I spell it? Occipital. Occipital. I don't know if I spelled this correctly. Occipital lobe. So this, okay. Okay, so again, here's my eye. And then I guess you could say it looks like a wire, which is the optic nerve. So the optic nerve is connected to the eye. And then it travels through the temporal lobe onto the optic radiation that travels to the occipital lobe. So right here is the back of your brain, and that is your occipital lobe, which is your vision. So the occipital lobe is your visual imaging. I'll say visual imaging. So it could see your colors, depth, objects, the shapes of the objects. So anything to do with your visual and perception. So, okay. So now I'll draw this brown line. Oh no, I'll use purple for the, it's basically called the imaginary line. So it travels back and forth from your eye to your, through your brain. So see that imaginary line axis? Okay. So what were the words? I should have put the, oh. Okay, so, we're talking about the occipital lobe, which is, okay, there's V1. So we're talking about V1, no, not V, is it V? Yeah, V1, visual primary 1, visual primary 2, and visual primary 4, and then the MT. Okay, so I'm going to put a box around these 4 different things. So 2, 1, 4. Okay. That's what I put down so far. So we got our optic nerve, which I was just talking about, right? The optic nerve is connected to the eye and is in the temporal. So it is in the temporal lobe. So it is in the temporal lobe. I'm just going to color it this pretty light blue, the temporal lobe. So that's the temporal lobe. Okay, so the optic nerve it has a bunch of axons combined. So, and an axon that I learned from the last and the axon that I learned from the last chapter is basically looks like, okay, so you have your dendritis, which kind of looks like flames. That's how I visualize it anyways. So anyways, that's like your dendritis right there. And then there's your here's your axon. So that line connected to the dendritis is your axon. And then you have your terminal axon. So then you have your terminal axon. So you got your dendritis, your axon, and then right here are your terminal axons. Well, the terminal axons connect to other dendritises. So they connect to other dendritises. So it's connecting to other dendritises. So you got your axon, your terminal axon, and then some more dendritises. Well, basically, that creates a bundle of axons. So those bundles of axons travel from the optic nerve to the optic disc. So to the optic disc, which the optic disc is about right here, to the optic chiasm. So optic chiasm. How could I draw this? So optic chiasm is like that I could remember. The optic chiasm was like in the middle. So the optic nerve exits through the optic nerve, exit through the optic disc, um, to the optic chiasm. So to the optic chiasm. So how can I do this? Okay, so the optic chiasm. So there I got the optic nerve, the optic disc, and then the optic chiasm. So the optic chiasm, I'm gonna get a pencil. The optic chiasm is, okay, this is one hemisphere and this is the other hemisphere. I'm gonna say this is my right hemisphere and this is my left hemisphere. So once it exits through the optic disc, it's gonna go to the optic chiasm. So the optic chiasm, sorry, I'm trying here. Let me see. Optic disc is probably right here. And then the optic chiasm. So optic chiasm. I'll use orange. I think I'm getting a hole in my paper. So here's the optic chiasm from the optic disc. Okay, so there's the optic. See the orange? I don't know if you could really see it. So the orange is right. The orange is right here. So you got your optic nerves, which is a bundle of axons traveling through the optic nerve, and then you got your optic disc right here, and then the optic disc sends signals to the chiasm. So the chiasm is supposed to look like an X shape, crossovering the hemispheres. So this is the left hemisphere and this is the right hemisphere. So the chiasm sends signals, half of the signals from the retina to the left side of the brain, and half of the signals from the right retina to the left side of the brain. So it's half and half. So for example, how can I explain this better? So I'm going to draw me another picture of a brain and the eyes. So I'll draw me another head. I am not an artist. So I'm going to draw me another head. The nose. Okay, so there's the nose, the skull, the back of the head, right? And then the mouth. Okay, so then there's so I'm going to put my eyes, right? So you won't see this eye because it's kind of, you know what I mean, in the back. But then you have this eye. Oh, that does not look good. So anyways, there's my eyes. And then my brain. So I got my optic nerves, right? Connecting to the brain. Then I got my occipital. So then the right hemisphere and the left hemisphere. Right hemisphere and left hemisphere. And then, so I'm going to color these in so they're better. And it's not the best picture, but it's the only way I could try to explain what is going on here. My optic nerves, my right and left. This is my brain. Okay, and my occipital. Okay. So my chiasm, so my optic nerve, so that's my new brain. That even looks worse, huh? So that's my new brain, and those are both the eyes. So I got my left hemisphere and my right hemisphere, my optic nerves that are connected to the optic, what's it called? The optic, oh my gosh, now I can't think. Connected to the exit. The optic, where the heck is it? Optic disc, the optic disc. I'm sorry, I had a fart in my head. So here's the optic disc. That's the optic disc. So there's my optic disc. So I got my eyes, my optic nerve, which is a bundle of axons that are exiting to the optic disc. Well, then from the optic disc is the chiasm. So the chiasm. So the chiasm is going to send signals from left to right. So the chiasm will send signals from left to right. So there's my beautiful chiasm, the optic disc, and then the chiasm. So from the chiasm, you have, okay, so you have your eyes, your optic nerve, which your optic nerve contains a bundle of axons, and they exit to the optic disc. Well, from the optic disc, it is connected to the chiasm, and the chiasm sends from the retina, which these eyes are your retina. Well, since the retina, so the optic chiasm from the retina sends signals from the right side of the hemisphere, from the left side of the hemisphere to the right side of the hemisphere. And from this retina, from the right side of the retina, sends some signals, half signals, to the left side of the hemisphere. So chiasm. I'm going to put right here, chiasm sends signals from the right hemisphere to the left, and then from the left retina sends signals to the right side. So right to left, so it's an X shape. And it only sends half. So half. So there's this. Sorry, I don't know if you could read that. So anyways, so those basically with the X, so basically with the X send signals to the occipital lobe, right? The occipital lobe, which is in the back of your head. So I got my eye, this is my right eye, and then this is my temporal lobe right here. So from my eye to my temporal lobe there is an optic nerve. So optic nerve, which travels then to this radius to through the chiasm. So some of the chiasm goes through my left side, and some of it stays to the right side, which eventually connects to the occipital lobe. So again, you have your eye, your optic nerve, which contains bundles of axons that exit through the optic disc. So exit through the optic disc that travels through the chiasm. So half of my right retina, half of my right retina signals travels to the left hemisphere, and then the other half stay to the right hemisphere. Same for the left. So I got my left eye, my temporal lobe, my optic disc, my optic nerve, and then that traveled through the optic disc, through the chiasm, half which will go to the right hemisphere, and half that will stay to the left hemisphere, which makes an X shape that eventually is all connected to the occipital lobe, which the occipital lobe is the visual lobe. Okay, so so now I guess we could move on to layers. I have these. I stressed about these last night. So I'm gonna put, so I can remember how to explain them, or I'm gonna write them down, what I remember. There's I think it's called the is it magnocellular? No, magnocellular, magnocellular, the magna, so think of great, cellular, so think of great, the magnocellular layer, which is 1 and 2, and it's the greater layers. And then you have so it's a magna. The magnocellular is the greater layers. And then you have your parvocellular, which means small. And then, so that's 3 through 6 layers. Parvo means small. And then you got your 3, and I honestly have a hard time pronouncing this word, but I think it's Koniocellular. So Koniocellular layer, which means extra small. Okay, so you got your magnocellular, which is great, your parvocellular, which is small, and your koniocellular, which is extra small. It's as small as grains of sand. That's what they were saying. So, how do I explain this? So, okay, you got your 3 layers. So basically layers 1 through 6, because you cannot see the koniocellular layers because they're too small to see. So you got your 3 layers. How would I explain this? The 3 layers. Okay, 3 layers. How would I explain this? Oh boy, I'm stuck. I'm sorry. So, okay, I got my magnocellular, layer, which, okay, magnocellular layer, which, oh my gosh, sorry, I can't remember. Well, it's like, okay, so magnocellular layer is the great cell bodies. Parvo is the small cell bodies. So I'm going to put great cell bodies. Small cell bodies. Oh yeah. Okay. So the great cell bodies I could remember. I hope I'm right. The great cell bodies you could see. What was it? Okay. Let me go to Parvo. Parvocellular, I remember they were saying that you could see color, depth, and shape. Color, depth, and shape. So the magno must be could see distance, motion. I hope I'm right. Motion, distance, motion. So yeah, so distance and motions. And then Kono, I think they were still saying that you could see maybe color, but they're not, I don't think 100% on that. So anyways, you got your magnocellular, your parvocellular, and your koniocellular. So I think, okay. Oh, okay. So now they were stressing really about the V1. So I got my V1 that sends signals to V2, which sends signals to V1 sends signals to V2, which sends signals to, what was it? Sends signals to, V1 is the V1 is vision. V1 is the primary vision. V1 is the primary vision. V2 is so V1 is the primary vision. V2 is the secondary vision. Okay, so sends to the, what the heck is that word? MT. I don't remember what the heck is MT stand for? Oh, it's the middle temporal. Okay, so it's in the middle temporal. Okay, so which you can see distance and motion. Okay. So V1 sends signals to V2, which sends signals to the middle temporal, which perceives distance and motion. And so, middle temporal. So I got my V1, right, which then sends signals to V2, which then from V2 sends signals to MT. And the MT is the middle temporal. So, and that is your dorsal pathway. And then you got your ventral pathway. Okay. which has signals of, okay, signals from V, let me think, signals from V, so 2 and 4, 2 and 4, no. So, okay, it sends signals from the visual, so visual primary, V1, and V2 into V4, which is color, depth, and shape. So the ventral pathway. So the ventral pathway of, should draw another brain, not another head, but another brain. Okay, or I could draw another head. Okay, so my eye, my optic nerve, my brain, right hemisphere and left hemisphere, the occipital lobe, okay. So then I have my axis. Okay. So then my MT. So then I have my axis, my optic nerve, which travels to the optic disc, and then the optic disc, which has the chiasm, optic disc, which has the chiasm. The optic disc has the chiasm. Okay, and then I have my, okay, my middle temporal, so the dorsal, front to back, front to back, middle temporal to the, so it goes to the V1 signals, which right here is the primary. V1 is the primary visual, which is V1. So from the primary visual to the V2 sends signals to the MT, which is in the middle temporal distance of motion, which is the dorsal pathway. Okay, and then the ventral pathway has, you have your V1, and V2 that travel into V4, Okay, and that is your ventral pathway. So V4, V1, and V2. Then this is your MT, right? I think so. Okay, so that's my picture I just drew. So I got my eye, my optic nerve, which my optic nerve, once again, my optic nerve carries all the axons from the retina into the optic disc, and then the optic disc sends signals from the signals to the chiasm, which this is the chiasm, and the chiasm sends, so it's the chiasm from the right side of the eye sends half of the signals to the left hemisphere to the occipital lobe, and also keeps some of the signals, whereas the left sends half signals, so the left sends half of its signals to the right hemisphere as well as keeping half of its signals in the left side of the brain. So half. So anyways, there's that chiasm, which goes to the occipital, and then you got this occipital, and then right here is the primary visual. The primary visual, which travels to, so for the dorsal, the primary visual travels to the primary visual travels to the visual 2 to MT, which has in control of the location and motion. So dorsal dorsal controls location and motion. Your V1 is about right here, which is the primary, and then you got your V2. That looks like a 4, sorry. You got your V2, which is your secondary, and then you got your MT, which is in the middle, and then you got your V4. Okay, so there's different layers of the occipital lobe. Different layers of the occipital lobe. Each layer of the occipital lobe controls a function. So, say if you damaged your primary visual, that could lead to color blindness. In which I was reading last night that I didn't know carbon monoxide could damage your occipital lobe. That is terrifying to really think about. And also what I remember is that there are 30 different distinctual properties in the occipital lobe that is just for the eye alone. 30 distinct. That right there could take alone probably a good 2 years of just learning all of that and really getting in depth of all of that. Because that is way too much to try to get in depth in just 12 weeks. Just a thought. So, I wonder if I covered everything. I think I did. Did I? Yeah, I think I covered everything. Okay, because this is my whole entire thing I showed you from the get-go, right? So this is my first picture, my second picture, I think. Yeah, and my third picture. So what I was learning again is that we have our eye, which is connected to the optic nerve, and the optic nerve carries tons of axons from the retinas. So then the optic nerve exits through the optic disc, and then the optic disc is connected, to the optic chiasm, which the chiasm is an X structure. So in the chiasm, from the right retina, you send half of your signals to the left side while keeping half still on the right side. And with the left retina of your eye, you send half of the signals to the right side of the hemisphere, while the other half stays on the left side of the hemisphere, eventually transversing all of these signals to your occipital lobe. And then in your occipital lobe, there is multiple layers. You have your magnocellular layer, which is great. Your parvocellular layer, which is small, and then your koniocellular layer, which is very small. So just right there are your layers of your occipital lobe, which is in control of your eye vision, your eye movements. Oh yeah, your eye movements. So we have our eye movement. Oh boy, let's see if I could even draw an eye. No, I'm bad. Okay, here's my eye. And then you have like your brainstem, your optic nerve, and then your brain. Well, on top of the is this like the stem. So I'll color the stem brown. Well, that controls the movement of your eye. So this brain stem controls the movement of your eye. Controls movement of eye. So there's that picture. So there's your eye, your optic nerve, which is your brain, and then you got your brain stem, which controls the movement of your eye. So hopefully I explained everything correctly, and I could go over it again just one more time of what I got out of this lesson. So I got my eyes right. This is my right side and this is my left side. Right, left. My retina, my retina is is part of like, to draw a better eye. Okay, so the retina. You got your eye. This right here. The thick part is your retina. So this thick part right here, this is your eye. This thick part right here is your retina. Okay, so anyways, back to the beginning. I have my right side and my left side of my retina. And then I have my optic nerves, my optic nerve from each eye that contains axons from the retinas. And they travel to the optic disc, exiting through the optic disc, which go to the chiasm optic chiasm. And the optic chiasm is an X shape. In the optic chiasm, you have half of your signals from your right side transversing to the left side, while the other half stays on the right side. And then you have half of your retinas from your left side transversing to the right side, while the other half stay on the left side, which is forming an X, which transverses signals to the occipital lobe, which is in the back of your brain, which contains all your visionary properties. And then in the occipital lobe, you have these layers. You have your magnocellular layer, which is 1 and 2, which is really big. Magnocellular layer, which is really big. And then you got your parvocellular layer, which is small, which contains layers 3 to 6. And then you have your koniocellular layer, which is really small, like grains of sand, which you can't really even see that. You can't see that in the technology we have today. But they all connect to one another. So for your dorsal pathway, it sends signals. The visionary primary signal sends signals to the V2, which sends signals to the MT, which is the middle temporal. And that right there creates distance and motion. Whereas you have your ventral pathway, which contains V1 and V2, which travels into V4. which you can see color, depth, and shape. Color, depth, and shape. So say if we ruined a part, our V1 somehow got ruined by, say, carbon monoxide or damaged by a brain tumor or something, in your V1, which is your visual primary cortex, could cause color blindness. And then say if you, I don't know, say if you ruined maybe, say if the V4 of your brain got ruined. I believe the V4, because it contains color, depth, and shape, could, if you ruin that somehow, you could cause agnosia, which could cause you to not be able to tell objects apart. You just see blobs of objects, which could happen to anyone. And so basically, depending on what part of the occipital lobe you ruin is what part of the visual problem that would occur. So it could either cause agnosia, which is seeing objects, identifying objects, or I cannot say this word, probignosia. Sorry if it's mispronounced, but that is relating to faces and not being able to identify faces. So this right here is my picture of the brain and eye, and I hope it was understanding. I hope you were able to understand what I was trying to get at this. And this again is for the Sensation and Perception class at the University of Northern Colorado. Have a nice day.